Okay, I'm going to go over a few problems here on page 649. I'm going to start with number 17 here. Packaging. There are 750 toothpicks in a regular size box. If the jumbo box is made by doubling all the dimensions of the regular size box, how many toothpicks will the jumbo box hold? So, I kind of drew a picture of the original one here, number 17. So you got this box. There's 750 toothpicks would fit in that box. We're going to make the jumbo size. We're going to double all the dimensions. So going left to right, I'm going to go double that. Going front to back, I'm going to double this distance. And then going even up and down, I'm going to double this distance here. And the jumbo size would look something like this. And then the question is going to be, well, okay, if this regular holds 750 toothpicks, how many would this one hold? Let's just say this is 1 inch this way. Well, if I double it, it's 2 inches. So the side length is 1 to 2, the ratio. You got to realize toothpicks fit inside the box. It's not going to be on the perimeter. You don't glue it to the area. It's space inside. And so how many of these boxes would fit in the jumbo box? Well, that's pretty much the key. And I'll draw it visually what it would look like. It would look something like this. How many of these boxes would actually fit in this bigger box here? And it's not going to be 1 to 2. It's not going to be 2 of them. There's going to be way more than just 2, because you doubled this way, and this way. So this is how you would do it with numbers. You would compare the side ratio. We are going to make it equal to, and when you talk about space inside where all the toothpicks are, this is really talking about the volume. And so we are going to compare that to volume ratio. Now before you are saying that the sides are equal to the volume, you must 1 way, 2 way, 3 ways. It's going to be doubled in 3 dimensions. So we can say 1 inch on the small, 2 inches on the big, and we're going to cube that is equal to 750 toothpicks in the small one, X amount of toothpicks in this big one, because there would be 8 of these boxes here, which are the same as this, that would actually fit inside this one box, because 2 times 2 times 2 is 8. And so this answer should be 6,000 toothpicks would fit in this jumbo size. Okay, but understand that when you say toothpicks, you're really talking about the volume, and you must cube it to equal the volume ratio. Okay, now I'm going to move on to number 18. Here's what 18 says. Packaging. A cylinder 4 inches in diameter and 6 inches high holds a pound of oatmeal. To the nearest ounce, how much oatmeal will a similar 10-inch high cylinder hold? Hint, 1 pound holds 16 ounces. So we've got 2 cylinders that are similar. I redrew this problem right here. They are similar. One has a diameter of 4, height of 6. The other one is bigger, has a height of 10. And they don't give the diameter, but it really doesn't matter. We already have a ratio of 6 to 10. Okay, this would also be in the same ratio, but we don't really need to worry about that. So we are really going to compare a side ratio and compare it to where does the oatmeal go? It obviously goes inside the figure. Inside the figure is volume. So we're going to basically compare the side ratios to the volume ratio. But of course, things triple. You go bigger one way, you get bigger radius, you get bigger in 3 dimensions. So what we're going to do here is go 6 to 10, and we'll cube that in a second, is equal to the volume. Now, oatmeal is really saying the volume. So 16 ounces of oatmeal to X amount here. We don't know how much would fit in here. Before I just go 6 times 6 times 6, I could do that. I'm going to reduce this down to divide by 2, 3/5. And then I'll solve this more reduced version. 3 times 3 times 3 is 27. 5 times 5 times 5 is 125. And then cross multiply and solve, and you will end up with about 74 ounces would fit in the bigger one. Okay. Okay, I'm going to do number 26 here on page 650. Let me just read it. I've already got the pictures drawn out, but 26. Two similar pyramids have a lateral area of 20 square feet and 45 square feet. The volume of the smaller pyramid is 8 cubic feet. Find the volume of the larger one. So I kind of just drew two pyramids here. Lateral area, volume, and our job is to figure out this volume. What we got to do is figure out what the similarity ratio is between the two triangles. The similarity ratio is not 20 to 45. We've got to figure out this similarity ratio, or the side ratio. We are given the area ratio, and what we're going to do is kind of work this problem backwards. This is 20 to 45, and if you want to go this way, you're going to take the square root of these numbers. But before I take the square root of 20 and 45, let's reduce these numbers. This is also divide by 5 on the top and bottom. This is actually 4 and 9. So we're going to take the square root of 4, which is 2, square root of 9, which is 3. So the similarity ratio is 2 to 3. So that's like 2 inches there, 3 inches there, or feet in this case, okay? Now we want to figure out the volume. We're going to need the volume using the similarity ratio. There's a relationship between this 2/3 and the volume ratio. If I want to go to the area, I square it. And if I want to get to the volume, I cube it. All right, so we're basically going to say the similarity ratio, we're going to make it equal to the volume ratio, but we're going to need to cube this guy. We've already calculated the similarity ratio by taking the area and going backwards. So we're going to say 2 to 3, and we'll cube it, is equal to the volume of the small, 8, to the volume of the big, x. So then you would just go 2 times 2 times 2 first is 8. This is 3 times 3 times 3 is 27. And then solve for this. And if you solve for this, cross multiply it, it should be 27 is the bigger volume. This should be in cubic feet. Okay. Remember, it grows in 3 ways, left to right, up and down, and it's even taller. It gets taller than the other one.